I'm Ewan Birney. I'm Deputy Director General of the European Molecular Biology Laboratory. Genomic data comes from individuals, and when those individuals are humans, of course those individuals have to be involved in whether they want their data shared, how they want their data shared. Now the rules for that are different, country by country, system by system. Here in Europe, many of them are governed by the GDPR process that European countries have signed up for. Regardless of the precise way it's done, whether it's in America or in Japan or in Europe or in Norway or wherever, very often there is a way for citizens and patients to indicate that they are happy to see their data shared. And when that does happen, when those individuals allow their data to be shared, we need to take responsibility for that data, but also use it for the benefit of all mankind. Now, I've been very lucky. I've been involved in a global organization, the Global Alliance for Genomics and Health, GA for GH, which helps set up the standards so that we can share from different countries to help everyone. This is standards in ethics or frameworks in ethics to have good discussions about that, but then also technical standards to make that sharing more easily. Life sciences, in particular molecular biology and genetics, has a wonderful heritage of openly sharing data. This started from the fly labs of Thomas Hunt Morgan and others back in the 1900s, 1910s, 1915s, where not only did he publish papers and the group there in Caltech published papers, but they also freely distributed the Drosophila fly stocks to allow other people to replicate that information. That idea of free distribution of the material and of data behind experiments continued in the 1950s and 1960s. In particular, Margaret Dayhoff in Washington put together a compendium of protein sequence information, which she again shared with everybody around the world. And this led to the large-scale databases that we have in the worldwide PDB around protein structures and in the ENA, the European Nucleotide Archive, and its sister databases, GenBank and DDBJ, worldwide. This predates the internet, and so as a community, we've been sharing information between scientists worldwide because we know it's the only way we can make progress. Now, in the late 80s and the 90s, the internet came along, it's become easier to share, and actually many other sciences have also taken on data sharing as a core part of it. We need to be reminded and proud of the history in the life sciences about how we share data, but continue to do it now and in the future because it's so critical. The only way we'll understand how life works is by sharing information and analysis from all of us around the world. Molecular life is an incredible process. We are machines, beautiful, amazing machines made up of many, many, many components. And we have to observe this in well-structured and well-understood experiments where we manipulate or control the way life works in some manner, and then we observe it, perhaps using biochemistry, perhaps reading the DNA or the RNA, perhaps looking at the images of these different molecules. But putting all of that information together requires sophisticated computational analysis. Now this is multivariate statistics at some level, but it's the biggest and most complicated multivariate statistical approach ever seen, and it requires real innovation on the computational side. These days, a big part of that is about using deep learning techniques, AI techniques, to help us manipulate and understand these data sets. So computational biology, statistics, and life sciences, molecular biology, have always gone hand in hand. But there's so much synergy between these disciplines in the future. They really are two parts of the same process of understanding life.